Okay, have a great panel.
Let's get started. I mean, I look like a huge crowd. I'm really proud. I mean, it's obviously late, and I'm pretty sure people are hungry, people are exhausted. We still get a good crowd. I mean, this is probably the best crowd we have, period. Thank you, guys. So what we try to do, I'm sure you guys agree. Let's try to wrap up as soon as possible. The good thing is they will not start dinner until we finished. So that's good news. All right, let's get started. And first, I think before the seminar, I look at the brochure. It looks like there was not enough introduction of the speakers. And let's get started with that. How about let's go ahead and do the roundtable. Let's quickly introduce yourself, what you do, which company you are, and let's quickly get that. All right, please go ahead.
My name is Dongyan Wang. Nice to meet everybody here on the panel. I'm in charge of the global AI team for Midea Group, in Chinese, Midea 集团. So it's the #2 consumer electronics company in the world, second to Samsung. We also acquired KUKA Robotics in 2016. So we're in the robotics intelligent manufacturing space. So our AI team basically has a R&D center here in Silicon Valley, about a mile from here, and also AI Research Institute in China, in Shenzhen, China.
Yeah, my name is Jonathan Huang. I'm the CEO of a company called Liftians. We're doing pretty much the same as what Amazon does in terms of warehouse robotics, and we program the whole thing from ground up, and then we use the Chinese manufacturing power to leverage the cost and the other technologies. Thank you.
I'm also Jonathan. I'm Jonathan Friedman. I'm that one that used to be up there. I'm the founder and CEO of a company called Assembly.com, and we make and install custom cameras and workstation terminals that we put into Chinese factories and warehouses to track and optimize the global supply chain. The thing that's unique about our approach to this is that we optimize our smart manufacturing technologies to work specifically with contract Chinese manufacturing relationships. That is to say, we are trying to use the technology to improve communication rather to optimize human relationships and human production factors rather than replace people with robots. So we think that that's a particularly interesting take on what it means to be smart about manufacturing.
My name is David Wang. I'm the CEO and founder of Beet. And we are a company dedicated to really, just like we said, connect humanity with machines. We create a software called Envision that we hope to digitize every single thing happening on the factory floor. We believe every machine, every process has a heartbeat, and we call ourselves the EKG for processes and machines.
All right, thank you guys. And it sounds like we have a startup, we have a multi-billion-dollar company, and that's great. I guess personally myself, by the way, my name is Xiang. I work for Arena. I'm a CTO of Arena. So what we do is we provide a platform for a lot of manufacturing company to do product lifecycle management as well as quality management. So I'm not expert on smart manufacturing, and I got obviously a good opportunity to learn from you guys. So let's start with the first question. You guys, from your own perspective, from a startup, from big company, what is smart manufacturing? Dongyan, you want to go first?
Okay. So I think in Industry 4.0, a lot of the news, you will see a lot of news talking about kind of the no-man factory or kind of no-light factory. We actually don't agree with that perspective because we don't believe we can to really eliminate the human out of the factory is really the point. That's not the point. The point is really to make sure increase the efficiency with robotics, with AGVs, with smart manufacturing processes, simulation, all those things to make sure human workers and robotics can really work together to increase the efficiency, because the current state of the AI really does not really offer to do all the complex jobs, using the robotics or other things. The logic we always use, because we work on AI for multi-billion dollar company in a practical way in a Chinese company. Chinese company is very demanding, as you know. And they demand all the technologies or solutions to be in the solution, in the product in probably 6 months to 1 year. So we're clearly not in the series space. So we really want to make sure, use the AI for the kind of the repetitive, simple, and dangerous or human don't want to do or shouldn't do. Those kind of the tasks are already good enough for us to automate and improve a lot of productivity for our factory, rather than trying to shooting for the kind of the nirvana in the next at least a few years.
Thank you.
Yeah, to me, anything that is socially responsible and plus anything that you will increase productivity by 10 times in theory. In reality, if it is 5 times, we should be doing it. Thank you.
I think that if you can summarize the entire history of manufacturing process optimization as 2 goals, right? Improving efficiency and improving consistency. Efficiency being, we want as much output for as few inputs, and consistency meaning that for the same inputs, we get the same output every time. So in that context, smart manufacturing, at least to us, means that you are doing a new generation of process improvement, and that means either seeing something new, measuring something new that you couldn't measure before, which is where a lot of these, sensor technologies and software, data collection processes come in, big data, that kind of stuff, and then it comes down to making processes that were previously static more dynamic, and that's where you see a lot of the software and algorithms. So that if the inputs come in a particular condition, instead of rejecting those inputs, we can adapt downstream parameters to use those resources more efficiently or correctly in a case where we couldn't use them before. All of that to us is smart manufacturing. So in our line of work, we spend a lot of time reaching out into new parts of industry, either new sectors or reaching down to ever lower tier factories. When you have a massive 50,000 square foot facility with hundreds or thousands of workers, there's budget and resources to invest in technology and bring process optimizations to bear. But imagine that you're just a family in a family workshop in a small village in Western China. What can technology really do for you? And that's the problem that we try to work on. So for us, smart technology is about seeing new things and making technology ever cheaper so that it's more accessible. Yeah.
Smart manufacturing really is with the least amount of input and create the most diverse output.
All right, thank you guys. I know that Dongyan, you work for Midea. Midea obviously is multi-billion, multi-international companies. You're responsible for strategic development, particularly in AI and smart manufacturing. So I guess the question for you is why people want to do that, and who benefited from this smart manufacturing?
Well, I think for any, especially Chinese manufacturing company, number one, we want to meet the customer demands, because a lot of the customer demands right now is not really about the generic products. For example, even for consumer electronics, we do build to order. So one assembly line may produce many different type of products, right? The same washer may have different color, different plates, different functions, different components. So the future manufacturing is definitely very different from the old days to produce simple, repetitive products. That's one. Also, quality is very, very important. As every company is shooting to really increase the profit, so quality and customer satisfaction is very important. So to make sure the quality not only at the end of the product line, for example, the cosmetic visual inspection, sound acoustic inspection, all those things need to happen, but also in the middle of the line of all the different component function assembly. So to be honest, if you look at all the manufacturers, at least in China, right, there are just a sheer huge opportunity to have this kind of AI-empowered or visual computer vision or acoustic-enabled applications to help the factory. Because even as for Midea, such a big company, and I would say it's advanced manufacturing in China, still there are huge room for improvements. So if from those angles, really the product manufacturing is really almost the bloodline for the company to start with, if you don't have good products. Another thing is, since we purchased KUKA Robotics, KUKA comes with an AGV company called Swisslog, and it has robotics. If you go to Tesla factory here in Fremont, you can see lines of KUKA robotics, right? So those really represent the future of the advanced manufacturing. Really have the robotics and the human to work together to make sure can deliver a product in a consistent way, right? And also, I like the chart Mr. Ma showed out there about the future, right? So to do the smart manufacturing, the first thing we have to have the factory digitalized, right? Without having the data, I mean, everything else you can do probably at the end, the visual inspection. That's probably all you can do. But if you want to automate and improve the whole process to do the diagnostics and all those things, there's a huge amount of work to do digitization. That's also the barrier for a lot of the companies because you almost have to basically spend a lot of money to automate, digitize your factory, right? And then before that, you can do other things. So it's important, at least from our learning, it's important to start with the point you can start, right? So we're not throwing in like hundreds of $1 million before 2 years to see the benefits, but rather try to say, where can you start to already improve the quality, improve the manufacturing efficiency, and then once you show that result to the company, right? In Chinese, you can say, we found the first stone in the river, then you can show them, hey, there are more stones in the river, right?
All right, thank you. Jonathan Huang. And before the seminar, you and I actually had a hallway chat. We talked about a little bit of smart manufacturing, and you actually mentioned something like, say, to be able to succeed in the smart manufacturing, you got to be able to monopoly, you got to be able to have a technical advantage. And why is that?
For any company, any society, any community, any group, any nuclear of something, a family, you have to have a form of a reason for existence. So a company was founded, so there's a reason for it to exist. Somebody want to put the money in it. Or if you don't have money, that's fine. Someone else will believe that you should exist. After that, there's a reason for you to survive. You have to survive. How do you survive it? Okay, we know that in our society, I mean Chinese culture, I mean, you know, my parents told me, you gotta study hard, you gotta go to this university and that. You have to have something. So what is something? Anything that exists or succeeds today, there must be some form of monopoly. I may not be really good at math, which I am, I'm sorry. But I have to be good at something. So same as a company, you must have a form of specialty, of monopoly. You must have monopoly. So monopoly is not that I take the control of the whole market. No. You always take the little piece of something in order to succeed. So let's go back to the AI and in Industry 4.0, I mean smart manufacturing. So for any company to succeed, you cannot really say something will happen in year 2030. For the meantime, I need $3.5 billion to reach that point. Because nobody would just, you know what, some investor would die by then. So anyway, so it is a constant struggle. It is an equilibrium point where you have a reasonable expectation into the return. So that's the monopoly. Monopoly of persuasion. If I persuaded Mr. Jonathan Friedman to give me $50,000 investment, so I have the monopoly power over him in terms of I get it. I get your ideas. You know what? Yeah, next year my money can be returned. So thank you. That's the monopoly power.
Thank you, Jonathan. Yeah, Jonathan Friedman.
Where do I sign? The 50,000?
You can do it tomorrow.
Done. Deal.
It's actually very interesting, Jonathan. I look at the website. You guys actually have a slogan called "Made in China and Done Right." So that's very surprising to me. It sounds like you guys actually do a lot of business in China as well. So the question is for you is how do we succeed? How can you or how do companies succeed in the smart manufacturing?
Well, I think that, you know, like we've been talking before, like the golden circle argument, you know, smart technology or smart manufacturing is a means to an end. It's not the end, right? So that's why our slogan is, you know, made in China, done right. It's not about what you're making or how you're making it. It's about, getting a successful output. And in our world, we focus on the human factors that, can be the greatest source of problem, in the form of human error, or they can be your greatest asset in the form of human innovation, right? So to really get success, at least in our view, from China, you have to get past the conventional model that's evolved here, and that is, companies tend to go to war with each other. It's a lot of economic violence, right? So companies will typically pay like 20 to 30% down on their manufacturing contract. Well, the factory is not making the corresponding 70 to 80% profit margin, right? So that factory has to invest, right? Which puts them at an extreme economic disadvantage. They're at risk. They have all their capital tied up in your product, and they only get the money back if you agree that their production met your quality standard, right? And in exchange for all that effort, what do they make on that? 1 or 2 or 3%, right? On top. Like, imagine if an investor were to kind of agree to put out, millions of dollars on those terms. Their LPs would laugh them out of the room, right? But that is the modern world of manufacturing, especially in contract relationships with Chinese production sites, right? And that causes a lot of problems if the production doesn't go well the first time, right? So that's the role that smart manufacturing can play. So we say smart manufacturing technologies have the greatest opportunity to change the world if they can improve communication, right? To make sure that the factory knows exactly what the customer wants, that the customer can supervise the factory in real time or very close to it, so that mistakes get caught and corrected quickly before you've made 10 bad units instead of 10,000 bad units, right? And that's the power of smart manufacturing, right? It's going to create new ability to see things we couldn't see before, right? Digitize the world, right? To create that precursor for further optimization. And it's going to make things that were previously inflexible a lot more flexible. We detected a problem, let's immediately change our process, let's roll that process change out, let's get the results, let's track those results, let's see if it worked, right? And to the degree that it can make things easier to see and faster to change, and more reliable when changes are made, that's the future, right? That is what smart manufacturing can do for the world.
That's great, thanks, yeah. David, you just gave a great presentation earlier, that's really, really nice. I mean, obviously, Jonathan also talked about, smart manufacturing. Obviously, you digitize data, you collect data, you analyze data, you make decisions based on those data. And as far as data, how important is production or product data analytics? Can you talk about a little bit, and how important is that?
It's really depending on the product you make and the complexity of the process, right? My background is actually, I started my career as a control engineer, worked for a company actually called Kamau, and doing large welding assembly lines for body shops, okay? And so when we started to deploy our technology, and we started at the body shop first, right? A typical body shops, if you make 250,000 vehicles a year, you're looking at 50,000 data points every 45 seconds we're collecting, we're visualizing them. But you can, another, you make glasses, like auto glasses. A line make, about 500 points every 60 seconds, right? You can make axles, depending on the complexity. So really, the more complex the process, the more data points you collect. Right? Yeah.
Okay. All right. Thank you. I know my background is enterprise software, and I've been in the field for almost 20 years. There are a lot of hot topics right now. There's AI, there's auto, which we just had a couple of seminars earlier. But for us, obviously, smart manufacturing, it becomes the center of enterprise for now. And we talk about benefit of smart manufacturing, which obviously we're all great and all the benefit. So let's look at the other side. Is there any drawback for smart manufacturing? Is there any concerns about doing it? You want to start?
Well, I think the danger, at least I can say, one is try to have really the process to be so limited and not flexible anymore. So because anything, sometimes human try to figure out things, we try to be smart and think about it can be a generic solution, but it always end up every single time cannot work for all the situations. So I think that's kind of one thing, because a lot of the systems I saw, at least from commercial solutions from the market, we evaluate a lot of vendors for smart manufacturing, because I'm also responsible for investment here in North America. a lot of solutions we found is more specific solutions tend to work much better than try to be kind of overkill, overarching solutions. I think that's kind of the danger we saw a lot of the startups and even big companies trying to do. We'll come in to solve, your manufacturing problem for a $35 billion company, which is not realistic, right? Because you don't even know what problem do I have yet, right? So I think the other side of the coin is really try to focus on specific business problem and try to really solve that business problem within the context of not the whole factory will be automated, AI empowered, no light, no man, probably in 10 years, right? There could be maybe a demo factory like that, but that's not every factory in China.
Okay, thank you. How about you, Jonathan? Especially you're developing a new system competing with Amazon Kiva. What do you think about that?
You raise a great question because we did a couple of POCs in China, and then they just point out exactly what you meant just now. So we have a system, of course. We know how, generally, the more the system is automated, the harder it will be rollback. So that's why eventually we came up with the idea saying, suppose, the worst kind disaster, everything gone. The whole system's gone, no hardware, no software. How do we recover that? Of course, we came up with the even better, fully automated system that can count everything from scratch in 10 times again, 10 times faster than human can do. So the reason that we designed the system in such a way that in theory, we always want anything that's better than 10 times, better than human. So that's how we can easily go to market to do that. The other thing about the recovery disaster consideration, how do you prevent that from being, say, hey, how do I know your system is working? So we start with something that's called simulation, as David Wang mentioned, that we start with everything that's digital. We digitize everything. So do we have a bunch of robots running with our system? Yes, we do. Do we compare them with what we do have? Exactly, because we use our simulated robots behave pretty much the same as the real robots, because we take all those, how fast it can run, how long it would take to turn that parameter into our system. So put it this way, we would say that the system is such as, highly simulated, pretty much the same as before you ever order Boeing 787, you get this simulator. You know how to fly it right away without ordering the airplane. So, of course, there are so many other ways, but from our experience, we feel that it's the most comfortable and the most convincing approach to the problem that you raised. Thank you.
Jonathan, in the process of making done right, what do you think about the challenge? What do you think about the drawback of this smart manufacturing?
Well, there's an old story about the turn of the century when they were electrifying New York City. There was an op-ed, now kind of infamous op-ed in the New York Times that was like railing against the idea of bringing electricity into people's homes, right? Like they're saying, people are going to get electrocuted. It's going to burn down buildings. People are going to die, right? And you know what? Every single one of those fears came true. But we electrified the whole, planet anyway, right? And that's just a question of, the benefits to a very large degree outweigh the risks. I think at a macroeconomic level, the biggest risk to smart manufacturing is that it will work, right? If I automate 10% of your job, you become much more productive. If I automate 90% of your job, you're out of work, right?
True.
And there's a lot of issues to think about, especially in the context of China, right, where such a large fraction of the under or lower educated class of people rely on what is essentially low or minimum skill labor right? And every technology or process you bring to bear that makes labor more efficient means you can use less of it. And it doesn't take long, as we saw kind of in this past election cycle in this country with all this emphasis on manufacturing and coal mining and whatever, right? Jobs that were essentially lost either to other macroeconomic factors or to automation and process improvement. Or technology change, right? Like it can destabilize a society, and so those are certainly things we have to look out for. Does that mean we shouldn't do smart manufacturing? Should we stop being more efficient? Should we all, use the cars we have with the current MPG or go back to riding horses? No, of course not.
Of course not.
Right, but these are things we have to be aware of and be careful about. Right?
Yeah, thank you. David, go ahead.
Oh, well, my biggest concern in a way is, smart manufacturing is ultimately good for humanity, but, a lot of times we don't think about what if something happens, we lose it. What's the backup plan?
Right.
Just like, year 2000, or suddenly the blackout happens, I think somehow as a society or a country had to think about if everything becomes smart manufacturing, what if something happened, the infrastructure happened, whatever, what's the backup plan? I think we cannot just think about the positive side. What is our backup plan when something doesn't work?
Right. David, you actually present earlier, you talk about a lot of challenges in the smart manufacturing. I'm going to give you one more question on this. What do you think about security overall in the smart manufacturing? Is that a big concern? David, yeah.
Yes. I think today, the technology that we're creating is, there's very strict restriction on factory floor today. If you go to a manufacturing, they have two networks, a plant network and then the office network. They have a very strict firewall protecting them, right? As smart manufacturing become more and more prevalent, what eventually, like I talk about, is from predicting to you eventually want to control. Then the security become paramount things. You do not want somebody somewhere and be able to turn on your robot or do something, right? I mean, that has to be developed. But today is really not a concern. Today we're trying to passively collecting the data, to analyze the data. Tomorrow, when you can control remotely or a cloud, a giant brain to control these things, then you have to be worried about that kind of stuff.
Yeah, I think security is far less a concern in smart manufacturing because there is always a firewall, or even worse, just cut off completely from outside internal manufacturing, and I don't think that's a concern for smart manufacturing.
Oh, really?
Yep.
Oh, okay.
I think one more point to add, at least for the next few years, because to the very point David mentioned, because a lot of the robotics in the factory right now is not remotely controlled.
Oh, okay.
It's actually controlled right behind the worker, and that's exactly the problem. You have the workers working there, they have the technician working on the robot. We want to have the more remotely programmed, configured, automated. However, that should be definitely within a firewall, within the company network.
Right, and also the problem is not about smart manufacturing. It is about the upstream data. Let's think about the smart manufacturing. It's about the integrated system, and smart manufacturing happen to be the last stop. So it's like a bus you carry, and then some guy hijack it. It's all it's the beginning of the route. But the smart manufacturing, no, it's not going to be affected.
That's an interesting point. Jonathan, what do you have last word?
Well, I would say that of course security. I mean, to split the difference right between Skynet and robots killing people, and it's never going to be a problem. I think it's definitely a problem. It's just that our domain has a real benefit in that you can think of our world as inputs and outputs, right? Sensors and actuators. So we will always have that bright line, that archetypical firewall that we can separate the networks. So right now networks are sort of like production network and office network, right? I think in the future it will be more like data network and control network. And the control network will be heavily protected, but the data network we can be looser so that we can get more of the benefits of efficiency and convenience. Yeah.
Thank you. I think we're about 10 seconds ahead of schedule. I know on the high level, I think Germany has this Industry 4.0 about a few years ago. Then China has this 智能制造for the next 10 years. I think US also have this so-called smart manufacturing. I truly believe this is going to be the future for the next 5-10 years, and there's a lot of potential over there. Finally, I want to thank the speakers. You guys stay long. And also, especially, I want to thank you guys, the audience, for sticking to almost 6 o'clock. Thank you very much.